SolidWorks 3D CAD software provides automated tools to help you design, analyze, and document your welded fabricated products. Design tools include a Weldment design environment that includes structural members, gussets, end caps, and automatic cut list generation. With Cosmos Analysis software, you can analyze structural elements as beams for rapid and accurate results, ensuring your design meets the requirements of real-world use. And of course, the SolidWorks world-class suite of drawing tools allows you to automatically transfer the design to a 2D drawing, including drawing views, bills of materials, cut lists, and hole charts. In this example, we are creating a welded frame for an engine used in a wood chipping machine. As you can see, we have already started the design by creating several mounting pads and an outline for our frame using standard SolidWorks 3D modeling and 3D sketching techniques. Now, let's create the frame. Tools for designing with standard structural members are provided in the SolidWorks Weldment environment, including an extensive library of standard structural members from around the globe. This will ensure that your regional requirements are met. You can also customize the structural members to your own standards. Once you have decided on a shape and size, in this case, ISO standard square tube 120 by 120 by 8 mm, you simply select the sketch lines that represent your frame. You have complete control on how the structural section profile is located relative to the sketch, and SolidWorks even zooms in to aid in viewing. Now you can select any location lock point for the section. SolidWorks lets you preview the results. When you are satisfied with your selections, the structural members are automatically created, complete with default corner treatments, such as this mitered corner. If you want another type of corner treatment, simply select a different corner treatment from the pop-up toolbar. Here we'll change these two corners to butt joints. Since we're going to make other frame members, let's pin this dialog open so we have easy access to it. Then we'll continue adding the remaining members of this frame. Many tools are available to get just the end treatments you need. Here, we'll trim off the cross-member material that extends beyond the existing frame members using another frame member for trimming. At this point in our design process, we want to ensure that our engine frame is strong enough. We also want to know how much it will deflect. For this, we'll use our CosmosWorks analysis capabilities, which are 100% integrated with the rest of SolidWorks. This means that your design and analysis all happen within one window in SolidWorks. An automated beam mesh speeds up the analysis of weldments, so you don't have to spend time setting up a complicated mesh for the analysis. The beam mesh capabilities allow you to treat all the structural members as beams. Of course, you will need to know what material the weldment members are made from to complete the analysis. So by default, we'll use the material we already assigned to the part. But if desired, you can easily select other materials. For example, in this case, we want to investigate having the frame made out of aluminum 2024 for weight reduction. Next, we'll define our joints, the place where the structural members are attached to each other. Again, this step is automated for weldments. SolidWorks selects all the joints for all the structural members in this weldment. We see that a few joints are very close to each other. CosmosWorks can merge these close joints using the pinball option. Think of it as a spherical selection tool that makes multiple joints, which are close together, act as one joint. Just drag the pinball to one of the joint pairs, and then drag the size of the pinball to encompass both joints. The next step is to set up how our frame will be constrained. We'll restrain the 4 joints on the lower section of the frame, and we'll load the upper portion of the frame to simulate the weight of the engine. We'll say 500 pounds. CosmosWorks gives you several options to apply loads. In this case, we chose to load the entire structural member. Notice that you can also select the units as needed, rather than forcing users to convert units. Let's run the analysis. In just seconds, our results are ready for review. First, we'll take a look at worst-case stresses, which are all color-coded for easy recognition in the high-stress areas. We can also animate results. For example, here we'll animate the deflection of the frame. Of course, this result has been scaled up so that the deflection is more evident. Let's continue on with our design. Next, we want to add gussets to the corners of the weldment to add strength. Gussets are easily created by selecting the adjoining faces and defining the size and position of the gusset. We can even create a 3D fillet weld bead if desired. All we do is simply select the appropriate faces on the gusset and structural members, and then specify the size of the weld bead. We can also apply the same weld bead to the opposite side in the same command. Next, we want to put end caps on the end of these open members of the frame to keep out debris. SolidWorks automatically creates an end cap based on the selected end face. You can even add an offset and chamfers if desired. Of course, SolidWorks also provides a wealth of 2D drawing documentation tools to ensure that accurate and clear information is communicated to the manufacturing floor, eliminating errors and scrap. For example, the cut list is automatically created, sorted by type and size of structural member. The ballooning of the assembly is also automatic and relates to the cut list. Individual parts requiring further detailing can also be included on the same drawing sheet. As you have seen, SolidWorks 3D CAD software provides a complete solution for the efficient and easy creation, analysis, and documentation of your welded structural assemblies.